Today we're going to talk about properties of exponents. When we first look at the product of powers rule, it tells us that if we have two powers, a to the m times a to the n, that all we have to do are add the exponents. Let's try an example that looks like that. So let's say a is 2 and m is 3 times a being 2 and n is 4. So the rule tells us all we have to do is keep the a the same and then add the exponents 3 plus 4, and that would be 2 to the 7th power, and that would be our answer. The reason why that works out is because 2 to the third means 2 times 2 times 2. We've multiplied 3 2's. 2 to the fourth means 2 times 2 times 2 times 2, which means we multiplied 4 2's. So if we multiply all these 2's up, we add them up, 1, 2, 3, 4, 5, 6, 7. Therefore, we would get 2 to the 7th power being the exact same thing. Let's try the next rule, which is the power of a power. That tells us that if we take a to the m and raise it to the nth power, we just multiply the exponents. So let's try this. 2 to the third power, and then let's raise that to the second power. So 2 to the third squared is, according to the rule, 3 times 2 is 6, so we multiply the exponents. We would get 2 to the 6th power, and that would be our answer. Why does that work out? Because 2 cubed squared means take 2 cubed, square it meaning multiply it by itself, so we have 2 cubed times 2 cubed. And just like the last problem, the product of powers, that's what we have here now, is 2 to the third times 2 to the third. So 2 to the third is multiplying 3 2's, that's multiplying 3 2's as well. And now we would get 2 to the 6th power, and that's the same thing as raising 2 cubed to the 2nd power. So then let's try the next one. The power of a product. So we're actually multiplying a and a b and then raising it to the m. What that's basically telling us to do is distribute the exponent m to both the bases a and b. Although it's not technically distributing, it's pretty similar. So if we have, let's go 3x, and we want to raise that to the 2nd power, this would be the same rule. We would just distribute the exponents, and that would give us 3 cubed times x squared. And that would be our answer. And that would work because all 3 squared means, if I were going to do 3 squared, I would do, or 3x squared would be 3x times 3x. And I made a mistake here. That's supposed to be 3 squared, not 3 cubed. So 3 squared times x squared is also what you would get if you multiplied 3x times 3x. Because you would multiply 3 times 3 to get 3 squared, x times x to get x squared. If we look at the next rule, the negative exponent, if we see a negative exponent, this is telling us that we just put the negative exponent on the other side of a fraction. For example, I can make this a to the negative n over 1, and anytime I see a negative exponent, I just flip it to the other side, and that would give me 1 over a to the n. So if I had an example here, like 2 to the negative third, that would be the same thing as 1 over 2 to the positive third. And that would be what we're looking at doing. The zero exponent rule, that's telling us that anything raised to the 0 power is always 1. So if I have 4xy in parentheses and I raise it to the 0 power, no matter what I put raised to the 0 power, that answer is always 1. And the last one, the quotient, or not the last one, but the next one, the quotient of powers, it tells us if we're dividing powers, we just subtract the exponents. So if I had 2 to the 5th over 2 to the 3rd, I would subtract the exponents 2 to the 5 minus 3, and 2 to the 5 minus 3 is 2 squared. And that would be how I would get the answer. The reason why that works is because 2 to the fifth is the same thing as multiplying 2 times itself 5 times. So I'm just multiplying 5 2's, putting that over 2 multiplied by itself 3 times. And then anytime I have a number on the top that's the same as the number on the bottom, I just cancel them out. So I cancel out the 2's there, the 2's there, the 2's there, and I'm left with a 2 times 2, which is the same thing as 2 squared. So that's how I get my answer in that one. And the last one is the power of a quotient. That's saying if I have some fraction and I raise it to an exponent, I just take the exponent to both bases on the top and the bottom. So an example here could be 4/3 to the fifth. So all I'm doing is just taking the exponent to both the 4 and the 3. So that would give me 4 to the fifth over 3 to the fifth. And then that would be the simplified answer. Let's try some other problems where we just have to determine what rule we're using. So here, evaluate the expressions. We have negative 2 to the seventh times negative 2 to the negative fourth. We have the same base, negative 2, and we have exponents. So all we have to do is add the exponents. Keep the base the same, so it's a negative 2. Add the exponents, 7 plus negative 4. And that gives us negative 2 to the third power. And since it says evaluate the expressions, we actually have to figure out what that answer is. This would be negative 2 times itself 3 times. So we just multiply negative 2 times negative 2 times negative 2, and that answer would give us negative 8.